Okay, hello everyone, and we'll continue our Mathcounts preparation. Okay, this is number 16 of the 2015 state sprint round. Number 16, what is the radius of a circle inscribed in a triangle with sides of length 5, 12, and 13 units? I will present to you three ways to find the answers. Okay, and the smart way, first, you should recognize that 5, 12, 13, okay, that's a right triangle because 5 square plus 12 square equals 13 square. And if you observe that 12 is roughly 2.5 times of 5, okay, so you simply draw a rectangle, right triangle, okay, with one side 5, then the other side, the other leg is approximately 2.5 of this side. So okay, that's 5. So it's 5, 5, then and a half. Okay, then draw the other side. That will be a right triangle. Then you draw the circle inside, inscribed inside. That's the biggest circle inside the right triangle. And if you estimate, you will see that the radius of the inscribed circle is smaller than 5, okay, and actually smaller than half of y. The middle here is 2.5. So you see it must be 2. Okay. But okay, y, okay, is not 2.4 or smaller than 2. That's because otherwise, okay, otherwise Mathcounts would ask you explicitly to give you answer in decimal format or in fractional format, or might be in a radical format. Okay, so because it doesn't ask any other format, so you can assume the answer will be an integer. So you don't have too many choices. So in this problem, you can just draw the picture and find the answer. Okay, another way, of course, if you want a sure answer, so let's say you know the formula. Okay, this formula will be handy. So if the sides of a triangle have length A, B, and C, we define the semi-parameter as to be half of the parameter. So that means half of the parameter. You add the three sides A, B, and C, then divided by 2. Then the radius of the inscribed circle is given by this formula. Okay. So that means, okay, you calculate S minus A, S minus B, S minus C, multiply together, then divided by S. Then you take the square root. Okay. So let's say H equal 5, B equal 12, C equals 13. Then S equals, okay, 30 over 2. You add them together, you got 30. Then divided by 2, you got 15. Okay. Then this S minus A, 15 minus 5, that's 10. 15 minus 12 is 3. 15 minus 13 is 2. Multiply them together, divided by 15. Okay. And the inside here, you should get 4. Then square root of 4 is 2. So if you have this formula, okay, it's a no-brainer solution. Okay, the third solution. And suppose that you don't want to take a risk to guess it, and also you don't want to use the formula, or you don't know the formula. Here's the way to find it. Okay, you know that 5, 12, 13, the three sides will form a right triangle. Okay, then you draw the inscribed circle inside, and okay, you estimate the center here, then draw the radius. okay, to the point of tangent here and here and here. Okay, we know that for any circle to be tangent to one side, okay, the radius, okay, passing through this point of tangent must be perpendicular to that line. So that's perpendicular, and this is a right angle. So we know this is a square. That's R, that's R. So that's also R. So this will be 5 minus R, and this will be AE will be 12 minus R. Okay, and how about this side? B and D, B to D, that's the same as B to F. So you have a circle here, you have a point outside the circle. If you look at the circle, okay, the circle should be symmetric to you. Okay, one edge, the other edge, it will be okay symmetric. So that's the two sides will be the same. So if this is 5 minus R, that's 5 minus R. Okay, then this side AD, the total is 13. So AD is 13 minus 5 minus R. 13 minus that will be 8 plus R. So, but you look at it, AD is the same as AE. So that means 8 plus R will be same as 12 minus R. And this will give you R equal 2, because you move this to the left side, you get 2R. You move this 8 to the right side, you get 12 minus 8 is 4. 2R equals 4, and this gives you R equals 2. Very simple. Okay, number 17. A bag initially had blue, red, and purple gumballs in the ratio of 2 to 3 to 4. 4 red gumballs are added to the bag. The probability for randomly drawing a red gumball is not 40%. How many gumballs are now in the bag? An easy assumption is that initially there were 2T blue balls, 3T red balls, and 40 purple balls. So look at here, the ratio 2 to 3 to 4. This should tell you something. Okay, if it's ratio is 2 to 3, so so that means the first part will be should be divisible by 2. You have 2 parts. Then the second we have 3 parts. So that means 2 to 3. Or you can expressing it might be 4 to 6 or 20 to 30. But you will have like 2 times a number, then 3 times the same number. Okay. Then how about the third the purple gumballs will be 4 times the same number. So we use the variable t here. So it will be 2t blue balls, 3t red balls, 40 purple balls, and you adding them up, it will be 90. Okay, 90. So let's say you add 5 red balls, okay, after, so it will be 90 plus 5. So now you have 90 plus 5 balls, but how about the number of red balls? Red in the middle, red, 3t. You added 5 red balls, it's 3 plus 5. So you know there are 3t plus 5 red balls. Okay, total number was 90 plus 5. If we divide them, okay, that should represent this 40%. 40%. But you know that 40% is 40 over 100, same as 4 over 10, that's 2 over 5. So, you cross multiply. Two fractions are equal, that means the cross products are equal. So 2 times 90 plus 5 is same as 5 times 3t plus 5. You simplify 18t plus 10, 15t plus 25. Then move this to left side, move that to right side, you get 3t equals 15, t equals 5. And so, total number was in the bag now is 90 plus 5, 90 plus 5. So it will be 9 times 5, 45 plus 5 is 50. Answer is 50. okay, mental solution. So that means they actually there is a smart way to find the solution. So let's do some thinking. Instead of writing an equation, okay, setting a variable t here, so let's do some thinking here. We know that 2 plus 3 plus 4 is 9. Okay, so that means, okay, if okay, the blue balls is 2, okay, something, okay, red ball is 3 something, purple ball is 4 something, the total will be 9 something. So that means the total number of balls initially in the bag is a multiple 9. Yeah. But instead of setting the variable here, let's look at the further information here. 40%, okay, we already know it's 2 out of 5. Okay, 2 or 5. So this means, okay, this is the ratio of the red ball currently right now in the bag. So after you added 5 red balls. So that means the total number of balls right now in the bag should be a multiple of 5 because, okay, it's 2 out of 5. So that means, okay, this 5, okay, total number of balls in the bag should be a multiple of 5. But if the total number of balls in the bag is a multiple of 5, that means total number of balls before you add in the 5 ball is also a multiple of 5 because total, okay, a number that's a number of 5 is subtract 5 is also a multiple of 5. Okay, so that means the total number of balls initially in the bag is also a multiple of 5. But what we also know is a multiple 9. So that means total number of balls initially in the bag is a multiple 45. 45 is a pretty big number. So we will try our luck. Let's see, okay. Let's say just try. The original number is 45. Okay, so that means if it's 45, that's total is 9. Okay, 45 is 5 times 9. So that means blue ball is 10. Okay, multiplied by 5. Red ball is 15. Okay, red ball 15. And 45, 15 out of 4. Okay, 15 out of 45. If we add 5 red balls, it will be 20. Then it will be 20 out of 50. 20 out of 50, voila, is 40%. Okay, so this checks out. So that means right now we have 50 balls in the bag. Number 18, the quadratic equation x squared plus px plus 2p equals 0 has solutions x equal a and x equal b. If the quadratic equation x squared plus cx plus d equals 0 has solutions x equal a plus 2 and x equal b plus 2, what is the value of d? Okay, if you think about this, you might just, okay, try something like, you put the x equal a there and put the x equal b there, you got the equations, then you get another equation, then, okay, put a plus 2 in the second equation, put the x equals b plus 2 in the second equation, get another set of 2 equations, then you will get a lot of equations and a lot of variables. Okay, that will be terrible. It will take you like several minutes, then you can never finish half the questions on the test. So what do we do here? You think about it. You only find this number d. So d is a number here. It will be an answer. So that means it doesn't matter what is A, what is B, what is P, etc. You will always find that number D. So what? We will, okay, be smart. We set P to be some specific number. In this case, the simplest one is P equals 0. Okay, so we just assume P equals 0. Then you see the fourth equation is x squared equals 0. X squared equals 0. The solution is 0. Okay, 0 squared equals 0. But another solution is also 0. There's no more other solution. So that means the two solutions will be 0 and 0. So that means A equals 0, B equals 0. Yeah. So in that case, what? The second equation, x squared plus cx plus d equals 0, has solutions x equals 2 because a is 0, and another solution is also 2, b equals 0. So you have two solutions. Okay, we know that for a quadratic equation to have two solutions, then the quadratic polynomial, okay, should be x minus the fourth solution times x minus the second solution here. So x minus this, x minus that. And if we just look at the constant term, d will be 4. Okay, negative 2 times negative 2 is 4. All other terms will be either here or here. So you see, it's easy to see that d is negative 2 times negative 2. Because you multiply this out, you will get x squared, then okay, minus 2x, then minus 2 times x, combined together will be negative 4x. So you find out that c is negative 4. But we just want to find d. D is negative, d is 4. Negative 2 times negative 2 is 4. So that's how easy it is. Okay, you just set p equals 0 there. So that's a smart way to do it. So what? If we don't believe this, let's try the unsmart way. Okay, that's not pretty smart. So in general, let's say x squared plus px plus 2p. It will be x minus a times x minus b. Okay, we will see a minus a is 0. If x equals b, b minus b is 0, that will be 0. So you have two solutions here. But if you multiply this out, okay, it's x squared, x times x squared, okay, minus ax, then minus bx. So you will combine together, you get minus that a plus bx. Then minus times minus, minus is plus, so you get plus a times b. Okay, combine the coefficients of x. So you should, okay, because p and b are given. So p should be same as this negative parenthesis a plus b, or this a plus b is negative p, same thing. Okay, that's a b should be same as 2p. So you get this. Okay, a plus b equals negative 2p, a times b is 2p. But we don't want to solve this, it takes time here. We just need to find a d. So what? We use this, x squared plus cx plus 2 plus d is same as x minus this solution times x minus that solution. Okay, or simply the constant term with the product of the two solutions. Okay, it's like here. Okay, 2p is the product of two solutions. It's AB. So the product of the two solutions will be d. D is the a plus b times b plus 2. You multiply this out, you will see that's symmetric here. That's symmetric. So you multiply this out, it will be expressible in terms of a times b and a plus b. Okay, a times b, then 2a, 2b, 2a, 2b gets the same as 2 times a plus b, then 2 times 2 is 4. And we know what is this. This is 2p. We know what is this. This is negative p. So you put them in here, okay, this is the expression of p in p. And actually, it cancels out nicely. You get 4. So the answer is 4. So you see that the answer does not depend on p. So our intuition is right. You can set p to be 0, okay, to get the answer. That's the easy way. You can set p to be like 1, okay. But if we set p to be 1, you might not find the a and b. So that's why we set p equals 0 here. Number 19, a rectangle of parameter 22 centimeter is inscribed in a circle of radius 16 pi square centimeters. What is the area of the rectangle? Express your answer as a decimal to the nearest tenth. Okay, let's see here. Okay, we know the parameter of this rectangle, but we don't know the dimension because it might be a square, it might be something like this. The width is longer than length or something. So okay, we cannot determine its dimension. But here, the circle, if we know the area, so we know the size. So that means we know everything here. So from here, we should know that the circle has radius 4. Okay, and radius 4 here. The diameter is 8. Why the radius is 4? Because the area is pi r square. R square. 4 square is 16. 16 is 4 square. So square root of 16 is 4. So the radius 4, then the diameter twice of that is 8. So if we draw here, will be okay. Circle diameter is 8, but the rectangle is inscribed inside here because of the symmetry. Okay, because of the symmetric picture of this rectangle here, the diagonal will pass the center of the circle. So this is a diameter. So it's 8, and we know the parameter is 22. Okay, then half of this will be 11. So that's why we set one side to be 8, and the other side will be 11 minus 8. Okay, because the total is 11, because you have 11 here also. So A, 11 minus A. Then the area of the rectangle is A times 11 minus A. But we still don't know what A is. But we want to find the area here. So we want to find this. We might not be able to find the A, but this is very important. So how can we find A, or the relation? Okay, the condition for A. Look at here. This is a right triangle. In a right triangle, you have the Pythagorean theorem. So a squared plus this side square, that's 11 minus a parentheses square, equals h squared. Okay, this is a quadratic equation. We can solve it, but remember here, solving a quadratic equation is expensive. We don't want to do that. So let's simplify it. Okay, a squared. You square this as this is 11 squared minus 2 times 11 times a, then plus a squared. Okay, remember that x minus y squared is x squared minus 2xy plus y squared. So it's 11 squared minus 2 times 11 times a, then plus a squared. That's 64. Okay, combine like terms, you got 2a squared. Okay, 11 squared is 121. That's minus 22a equals 64. But I don't want to multiply this out. Okay, let's see here, because there's a 2 here. There's a 2. I will take this 2 out. Okay, which is okay. If I move this constant term to the other side, I will get a negative number because 121 is bigger than 64. I don't want to do that. Instead, I want to move that 64 to the left side. Okay, 121 minus 64 will be 57. That's a positive number. I like positive numbers, especially when we solve geometric problems. Okay, you don't want negative numbers. That's it. So you move this to the left side, you get a positive number. So I move everything else involving variable to the other side. So you get 2 times 11 times a minus 2a squared. So look at here. I take that 2 out. Then you get, okay, 11a minus a squared. I take a factor a out also. Okay, but I don't need to. Let's see here. Take the 2 out. 11a minus a squared equals 57. But this one, compare here. That's the same thing. Same thing. So they divided by 2. Okay, you get 11 minus a squared, which is the area, is 57 divided by 2 is 28.5. So you see, you don't need to find a. So that's the key here. If you go to find a, it will take you a lot of time. Then you will miss all the other easy questions. Number 20. The units and the tens digits of 1, two-digit integer are the tens and units of digits of another two-digit integer, respectively. If the product of the two integers is 4,930, what is their sum? So this practically says there are two-digit integers. Okay, another one two-digit integer, another two-digit integer, and their unit digits and the tens digits are exchanged. So that means if the first one is okay A B, okay, A is first digit, B second digit, the second one will be B A, and the product of the two integers is this number. So what do we do? That's a pretty big one. So you might try all of them, then you will never find the solutions and you will get time out. So, what you do, you look at this one, okay? It looks big, but I'm sure that it will not have too many factors. So if you try factor it, you might find the answer. So, that's a quick way because there's no other way to do it. Because if you guess on those two numbers, you will have a lot of options and you multiply those numbers, and that will be terrible. So that means we just look at this one and looking for clues. Okay, so because the product of two numbers is this, so we'll factor it. Okay, easy one is 10 times this. Okay, and the 10 is 2 times 5, but that's 493. Looks like it's pretty big. It's not divisible by 2 or 5 or even 3, because look at here, 4, you add them together, it's not a multiple of 3. You add the digits, it's not a multiple of 3, so it's not divisible by 3. And if we divide it by 7, okay, this is divisible by 7, but 3 is not. So it's not a multiple of 3. It will not be a multiple of 11, but you keep trying anyway. You will find out it is divisible by 17. So you only look for prime factors 493. You will find out it is 17 times 29, and 29 is a prime number, 17 is a prime number. So you stop. That's a prime factorization. So the two digit numbers will be product of those numbers. Okay? But one observation is that 2 and 5 cannot occur in any one of those single integer, because if 2 and 5 occur in one of them, then it will have the unit digit 0. That would be wrong. So 2 will be one of them, 5 will be the other of them. Then you just try 15, 17 with 2, or 29. Okay, look at here. If you try 29 with 5, 29 times 5 will be a 3-digit number. That will not work. The only way it work will be 5 times 17. The other number is 2 times 29. So actually 5 times 17 is 85. 2 times 29 is 58. Look at here. The digits, they just exchanged. So this worked. So that means, okay, look at here. That's 85. That's 40. Okay, that is 58. That is 85. Multiply together 4,930. So we find the answer here. One of them is 85. The other one is 58. The product is 4,930, and we want the sum. So you add them together is 143. Okay, that's all for today. Next time we will continue number 21. Stay tuned.